Hello everyone, and welcome to the grids lecture for the seaborn section of the course. In this lecture, we're going to learn how to use seaborn's grids capability to automate subplots based off of features in our data. Let's go ahead and jump to the Jupyter Notebook to get started. Okay, here I am at the Jupyter Notebook. I went ahead and said import seaborn as SNS, called matplotlib inline, and then I uploaded the iris dataset. And you can do that just by saying sns.load_dataset and then passing the string iris. And checking out the head of this iris dataset, this is a pretty famous dataset. It's basically just measurements of a bunch of different flowers or irises, and the last column here on species has three distinct types of values. So if I go ahead and say Shift Enter here and call iris, check out species, we can check out the unique values here. And there's three species of flowers possible. It's either setosa, versicolor, or virginica. And the other four columns are just features of the flower, such as sepal length or petal width, etc. We're going to see much more of this data set when we talk about machine learning, but for now, let's just go ahead and do a simple pair plot on this data. So pair plot is kind of the automated joint plot for the entire data set. So remember from the distribution plot lectures that we can just pass in the data frame, and it will automatically create this pair plot for us. Now, using seaborn's pair grid mechanism, we're actually going to be able to customize this sort of pair plot with a lot more control over the actual plot. Let's go ahead and show you how we can do that. I'm going to go ahead and call pair grid instead of pair plot. And pair grid is going to be capital P AIR, capital G RID, and then your data frame. So we have pair grid, and this just gives us an empty pair grid. So it takes all the numerical columns and grids them up, essentially kind of making these subplots for us. And pair plot is just a simplified version of pair grid. So pair plot does a lot of this stuff automatically. Pair grid, you have to do a little more, but it gives you a lot more control. Let's go ahead and see how we can use it. The main way is to set this pair grid equal to a variable, and then off of that variable, you can map plot types. So for instance, if I want to go ahead and map maybe a scatter plot, I can say plt.scatter, and this will map a scatter plot to both the upper diagonal, the diagonal itself, and the lower half. Now, if I want to actually specify what I want on the diagonal, upper half, and lower half, I can specify that command by saying map_diag, and this will be the diagonal plot, and we just go ahead and map something to this. So let's go ahead and map a dist plot to the entire diagonal. And then I'm going to map on the upper plots. We'll go ahead and keep that scatter plot mapped just on the upper. And then on the lower, map_lower, I can plot some other plot type. For instance, KDE plot. Alright, and notice here I'm not closing the parentheses off of these plots. I'm just passing in the plot function itself. And it's going to map it based off the data to either the diagonal or upper or lower places in that matrix. So we can go ahead and check that out. This may take a little while to run depending on how fast your computer is, but now we can see we have this sort of pair grid or pair plot, but we have a lot more control over it. Instead of just being scatter plots and histograms, now we can actually choose what plot types we want to map. And that's just the basic idea behind pair grid. Usually we'll just use pair plot since it's simpler and gives us most of the information we want. But if you're ever trying to get a little more customizability out of the seaborn plots, especially pair plot types things, you can use pair grid to do that, and then map the whatever specific plot types you want to the diagonal, upper, or lower. Now let's discuss facet grid. In order to discuss facet grid, I'm going to go ahead and clear this, and I'm going to load the tips dataset by saying tips is equal to SNS load dataset, and then passing the string tips. Check out the head of our dataset. Alright, we have our tips dataset that we're familiar with. Let's go ahead and just show you a very simple example of a facet grid by just showing the grid. Similar to pair grid, I'm going to call, let me go ahead and zoom in here a little bit. I'm going to call G is equal to SNS.facet grid. And then for facet grid, what you do is you pass in the data. So you're going to say data is equal to, or as the first argument, you don't have to say data equals. You can just pass in tips. And then you specify what you want the call to be, and what you want the row to be. And this is kind of similar to when we were using subplots with matplotlib, except now instead of saying numbers, you're actually going to pass in column names of your data frame. So for instance, I'm going to say call equals time, and row here is equal to smoker. Let's go ahead and run that and see what that looks like. Okay, now I have an empty grid, and I can begin to actually map plot types to this grid. For instance, I'm going to go ahead and say g.map SNS, let's go ahead and do a dist plot, and let's do it on total bill. So let's go ahead and do that. Let me close that out and run this. Okay, so what's actually going on here? I am mapping a plot type and separating the results based off of, by column and row, certain column names. And here they're labeled for us. So the x-axis represents total bill, but there's 4 separate plots, and they're actually labeled for us. So yes and no on smokers are the rows, and that was specified when I said row equals smoker. And then yes or the actual time of lunch versus dinner is specified by the column. So the left column is lunch, the right column is dinner. The top row is smokers, and the bottom row is non-smokers. And then we have distribution plots for the total bill column. So there's essentially kind of 3 arguments at play here. The rows and columns names, or what variables you want to separate by for your facet grid. And then when you're mapping, you're going to want to add in one more argument for what you actually want to map or display. If you're trying to map a plot type that needs more than one argument, so we know this plot only needs one argument, but let's say we try to do a scatter plot by saying plt.scatter. If I just said total bill here, I'll get a type error. What I need to do is pass in an additional argument. So I can go ahead and pass that in, and we can say maybe tips versus total bill, and we go ahead and run that. And this actually just needs to be tip. So tip versus total bill. Now we can actually see that we have tip versus total bill, and we've separated both on row and column on smokers and lunch versus dinner. So if you're dealing with a plot type that needs more than one argument, you just add that in as a second argument in the map call. Alright, that's actually it for the grid lecture. And the reason for that is because we won't actually be using facet grid that often throughout the course. Seaborn's basic plotting capabilities are actually quite enough for us throughout the course. These sort of grid functions are only here for you if you want to customize your plots even further. And there's a link in the Jupyter Notebook for this lecture with some links to the documentation and more examples of what you can do with facet grid and pair grid. But just keep them in mind when you're looking for a little more customization. Some other plot types, such as regression plots, actually have parameters you can pass that will automatically create a facet grid for you. And we're going to explore that a little more when we talk about regression plots in the next lecture. Okay, thanks everyone. Feel free to post in the Q&A forums if you have any questions on this topic. I'll see you at the next lecture.